Hello friends, in the last few videos we learned about the Peasant mapping of any transfer function, and we also learned about the open loop and the closed loop transfer functions. In this video we'll be learning about the block diagram analysis, that is, if several transfer functions or several blocks are placed in few particular ways, that is in series, parallel, feedback, and whatnot, how to find out the equivalent transfer function of such a structure. The rule 1 is called the series rule. The series rule. The series rule says that if we give an input, there is a transfer function g1 block, there is another transfer function g2 block, and this is the output. The equivalent transfer function would be, if we replace it by a single block, the equivalent transfer function would be g1 into g2. That is, if there are n number of blocks, that is g1, g2, g3, g4, suppose the equivalent transfer function would be the product of each transfer function, that is, the product of the gain of each transfer function, that is g1, g2, g3, g4, right? So that is the series rule. Now that will be the total gain factor, right? Now moving on to the next rule, that is the parallel. Rule number 2 is parallel. Let's say, now the parallel rule says that suppose there is transfer function, that is a block g1 out here, another block g2 out here. Now the equivalent transfer function, if we calculate from this and be replaced by a single block, the equivalent transfer function would just be the sum of the two blocks. Okay, g1 g2, sorry, g1 plus g2. If it were in series, it would have been g1 g2. As it is in parallel, it is g1 plus g2, right? So that is the parallel rule. Now what I'm trying to do is, we'll be talking about all the rules together and then we'll be solving one or two big problems from books, right? So number 3 is the rule of feedback. The rule of feedback. Suppose there is a transfer function g1, h1 out here, right, h1 out here. So we know that this is the closed loop transfer function formula. So the whole transfer function, if we write it together, we know what this transfer function would be. It would be g1 by 1 plus g1 h1. We know that this is the closed loop transfer function formula that we have derived already, right? So this is rule 2, that is feedback rule. Okay, rule 4, that is we are going to talk about, that is the takeoff point. So first of all, we need to know what is the takeoff point. Okay, what is the takeoff point? Suppose this is a block, suppose g1, we are taking this and we are giving it to another block, suppose g2, this and this goes elsewhere, right? So this point is known as a takeoff point. Why is this known as a takeoff point? Because we are taking the signal from here and we are putting it into some another block. So now we can do two things with takeoff points. This is takeoff point before the block, takeoff point before the block. Suppose for some purpose we need to move this takeoff point beyond this block. Suppose we need to do so. Like we need to do like this. We need to convert it into this type of structure. So what will be these blocks now? This block would be the same. This block would be g1. This block, that was g2, it would now be g2 by g1. We'll explain to you why this is happening. Suppose a signal x is coming into here. Okay, so this, suppose in the s domain only, so this signal becomes x into g2, right? x into g2, right? And this becomes x into g1. We now also x comes, we are transferring the system, but we want to get the same output only, we cannot change the outputs, right? So the system is modified in such a way that here, if this is x, this is xg1, so this is xg1 only. This point will also be definitely xg1, so we are getting at it as it was. But here this point we should get xg2, thus we are multiplying it by g2 by g1, so that g1 cancels and we get xg2, right? So just remember the rule that if a takeoff point is taken after a block, then it is divided by the block gain, right? The reverse can happen also, that if this is g1, this is g2, so this is the takeoff point, this is the takeoff point, right? If you want to take the takeoff point before the block, we'll simply have to do the reverse, that is multiply with the block gain, that is we'll have to do g1 g2 out here, right? Simple, because if this is x, then we used to get x g1 out here, this is x g1, so to get x g1 g2 out here. So if this is x, this gives me x g1, this gives me x g1 g2, right? So this is the rule of my takeoff point before a block. When we move it after, formula is the block gain is divided, and if it is after a block, if you move it forward, it is multiplied. Remember this. Now another type of point is the summing point. So the rule of summing point is almost the exact opposite of as it was in the takeoff point. Now let's see the summing point rule. Summing point rule says, suppose this is my GS that is coming, right? There is a summer, my XS that is coming, right? Now we want this is called a summing point. We want to move this before this block. What do we have to do if we want to move a summing point before a block? Okay, we need to divide it by the block gain. Previously what it was, that if we wanted to move a takeoff point before the block, we needed to multiply it as we saw. We wanted to move it before the block, we multiplied it. Here it is divided, and we'll explain it why. First let me draw this. This would be g1, okay, g1, and here also would be multiplied by g1, and here is x, right? Let us see here, if this is my y, okay, here we'll get this would be my y into g plus x, so this would be yg plus x, right? Here if we give a y, so here in this point we get y plus gx, right? We get y plus gx. Sorry, I was doing something wrong. Here it was multiply, right? So here it would be divide. So this is x by g, y plus x by g. This multiplied by g1 again. That would give me g1 into y plus x by g, right? So this would give me y g1 plus x, as it was in the previous thing. So this is the equivalent model if we move the summing point before a block, right? So we moved the summing point before a block, and thus we got this type of diagram. So it will be the exact opposite if we move the summing point after a block. So just remember, take off point, summing point, right? Before, after. If you move a takeoff point before a block, if you move the takeoff point before a block, what happens? Multiply. So summing point will be the exact opposite, divide. So here if this is multiply, this would be divide, this is divide, this will be opposite, multiply. So you just need to remember one and all are the opposite. This is multiply, so this will be divide, this will be divide, this will be multiply. Okay, just remember this. block, and you'll be able to do takeoff and summing point problems from everywhere. Now this is almost all of the rules of block diagram solving. In the next video, we'll be solving an example of block diagram analysis. Thank you for watching.